Hello students and welcome to Unit 4 Lesson 6. In this lesson, titled Equations with Squares and Square Roots, we will answer the following essential question. How do I solve equations that contain squares and square roots? Now think about what we already know. We already know that to solve equations, we first simplify. And second, we use inverse operations to isolate the variable. The same is true when our equations have squares and square roots. We will use inverse operations to isolate the variable. Let's first talk about the relationship between squares and square roots. Here's your question. What can we do in order to undo a square? So for instance, if we have the number 9 and I square the number 9, I give it an exponent of 2, I get 81. 9 times 9 is 81. What can I do to 81 to get back to 9? Well, I could square root 81. The square root of 81 is 9. And what you just showed was that a square root will undo a square. In other words, they are inverse operations. The opposite is true as well. What can we do in order to undo a square root? So for instance, if we start with the number 16 and we square root it, we would get 4. Well, what can we do to 4 in order to get back to 16? Well, we can square it. We can times it by itself. 4 times 4 is 16. And what we just proved was a square will undo a square root. They are inverse operations. So let's first look at some examples of equations that contain squares. Here we see that x is being squared. So if you created a do and undo chart, which would only have one operation because there's only one operation on this side of the equation, we would say that x is being squared. And the opposite of squaring a number is to square root a number. So if we square root each side, the square and the square root will eliminate because they're inverse operations, leaving us with just x remaining. So x is equal to the square root of 121. Now, the square root of 121 is 11, so x is equal to 11. However, if you think about this, 11 times 11 is 121, but isn't negative 11 times negative 11 also 121? Because a negative times a negative is a positive, so we get 121. So when you write your answer to the square root of 121, you could say that it's positive or negative 11. Either one of these numbers, when squared, will equal 121. Alright, in this one we have a squared. A squared plus 11 is equal to 180. If we subtract 11 from each side, we will eliminate the constant because positive 11 minus 11 makes 0. So we get a squared equals, and if we subtract, we get 169. If we square root each side, a is equal to the square root of 116, which is 13. And just as we learned, it would be positive or negative 13. Now, a lot of you struggle when the variable is not the first term on this side of the equation, so you can create your do and undo chart if necessary. Well, if we knew what y was, we would have to square it, and then we would have to add 700 because this is a positive 700, not because of this symbol here, but because this is a positive 700. So we'll put add 700, so we're going to have to subtract 700 from each side, and then square root each side. So we'll subtract 700. 700 minus 700 is 0, so we get y squared equals, we get 5, 2, hold on, 5, 2, 6. So we get y squared is equal to 625. Now, as our second step in our undo, we will square root each side. The square and the square root will eliminate because they're inverse operations, but what we do to one side, we have to do to the other. So y is equal to, and the square root of 625 is 25. If you didn't know that, you would have to guess and check over here and see that 25 times 25 will give you 625. So we know it'll be positive or negative 600, or sorry, positive or negative 25. All right, in this equation, notice the square is acting upon a difference. So if we create our do and undo chart, we would know that if we knew x, we would have to subtract 7 first and then square it. Okay, so we're going to have to square root first and then add 7. So if we square root both sides, the square and the square will eliminate and we'll get x plus minus 7 is equal to positive or negative 5. Now, when we know that x minus 7 could be one of two numbers, we're going to have to branch that out to make two separate problems. So x minus 7 could be positive 5, or x minus 7 could be negative 5. Now add 7 to each side. We get x is equal to 12. If we finish this equation, we get x is equal to 2. Now, can it be both 12 and 2? No, it's one or the other. Both of these numbers will make this equation true, and I can prove it to you. Substitute them back in. 12 minus 7 is 5. 5 squared, 5 times 5 is 25. So this makes it true. Substitute 2 back in. 2 minus 7 is negative 5. Negative 5 squared is negative 5 times negative 5, which is positive 25. So these two answers will both make this equation true. All right, let's look at another example. We have 3 times x squared. If we make a do and undo chart, we would first have to square x and then multiply that by 3. So to undo this, we're going to divide by 3 and square root. So we're going to divide each side by 3. We get x squared equals 400. And we're going to square root each side to eliminate the square. So we get x equals the square root of 400, which we know is 20. So the only values that will make this true are positive and negative 20. Now, if square roots are the inverse of squares, then what is the inverse of a square root? A square is the inverse of a square root. So we're going to look at backwards this time. We're going to look at equations that have squares, have square roots, and use a square to eliminate that operation. So in this problem, we have the square root of x. So if we knew what x was, we would square root it. But since we do not know what x is, we will have to square it in order to determine what it is. So we're going to square both sides. A square and a square root eliminate, and we get x equals 16 squared, or 16 times 16. For time's sake, I'm going to show you on the calculator that 16 times 16 is 256. So x is equal to 256. And if you multiply that out, you get the same thing. The square root of x plus 11 is equal to 60. If we create a do and undo chart, if we knew what x was, we would have to first square root it because that is a grouping symbol, and then add 11. Notice the 11 is not underneath of the square root symbol. It's not a grouping, it's not grouping the 11 with the x. Now, to undo that, we'll have to subtract 11 and square each side. So we'll subtract 11 from each side. 11 minus 11 is 0, so you get the square root of x equals 49. Now, our last step in undoing this equation is to square both sides. The square root and the square will cancel out because they're inverse operations, and we get x equals 49 squared. And if you multiply 49 times 49, you get 2,401. So the only value of x that will make this equation true is 2,401. This problem is very similar to the last, except that the algebraic term is on the right of the constant. So if you make a do and undo chart, you're going to see that we would first have to square root x, and then we'd have to add 100 because it's a positive 100. So to undo this, we're going to have to subtract 100 and square each side. So we'll subtract 100 from each side. 100 minus 100 makes 0. So we get the positive square root of x, or just square root of x, equals 400. So we're going to square each side. The square and the square root cancel out, so we get x equals 400 squared, which would be 400 times 400. Well, I know that 4 times 4 is 16, and we would need 4 zeros, so we get 160,000. That's the only value of x that will make this equation true. For this problem, create a do and undo chart. If we knew what x was, we would first have to square root it. Then we would have to multiply by 9 since they're touching. That means multiplication. So to undo it, we're going to have to divide by 9 and square. So we'll divide each side by 9, and we get the square root of x equals 62. I'm just going to double check my mental math. 558 divided by 9. 62. Okay. Now we're going to square each side. The square and the square root will eliminate since they're inverse operations, and we get x equals 62 squared, which means 62 times 62, which is 3,844. This is the only value of the variable that will make this equation true. Let's look at one more example and then we'll summarize. This is a 3-step equation. If we knew what x was, we would first have to multiply by 3 because it's in the grouping symbol in the parentheses. Then we would have to add 10, and after we got that number, we would have to square root it. So to undo this equation, we're going to have to square it, subtract 10, and divide by 3. So the first step is to square each side. The square and the square root will eliminate since they're inverse operations. We'll get 3x plus 10 equals 16 squared. 16 times 16 is 256. Now we'll have to subtract 10 from each side. 10 minus 10 is 0, so we get 3x equals 246. Divide each side by 3. We get x equals, 3 goes into 24 8 times, and 3 goes into 6 2, so we get that x is 82. That is the only value of the variable that will make this equation true. So let's summarize what we've learned. We've learned that squares and square roots are inverse operations. They will undo each other. And when an equation contains a square or square root, we can create a do and undo chart to help us know the order in which to solve the operations in the equation.